Okay, now one thing to remember that in some of these problems, they're not going to actually tell you to use the kinematics equations. It's kind of up to you to figure it out. Now, these are used when there's a constant acceleration. So you're really identifying the things information that you have, which in this case is you've got a distance of 200 meters. You've got a time of 8.5 seconds. And you know that the initial velocity, if they start from rest, must be equal to 0. So kind of look for all those things. You don't know the final velocity, but you are being asked to work out the acceleration, so that's your unknown. So when you start looking at these equations, you're looking for one that's going to work for you. So which ones have the distance in it? Well, this one has distance, this one has distance, and this one has distance. Okay. Now, we're not going to be using these ones because they're just your kind of normal equations which don't necessarily apply to these situations where you do have a constant acceleration. So when we're looking at this, we will see, well, in this one we need to know the final velocity, which we kind of don't know, and it doesn't have acceleration in there as well. This one has acceleration in here, but it has you need to know the final velocity, and in this one seems to be just right. Okay, apologies, I'm sick at the moment, so I'm trying to do this while I'm sneezing and coughing, but this is the only one that has the unknowns that you need. Now, sometimes you can use a combination of them to work out, maybe the final velocity or something like that. So you write that down, distance equals VIT, and remember you've got to really show your working as well. So then you just replace it with 200 meters. Now, because the initial velocity is equal to 0, 0 times t is going to be 0, so we'll just kind of leave that out at the moment. Plus, so it's going to equal half times a times t, which is 8.5 squared. Now, in these, remember you've got to square this, initially. Okay, now I've just rewritten this over here. So it's still 200 meters over here, equals half times acceleration. Now that's just 8.52 squared. That's what that is. So we then we're timesing by half on this side, so we then divide 200 by half, which equals 400, equals 72.25 times a. So if we do that, 400 divided by 72.25, that equals 5.53 meters per second Now, if we do that to two significant figures, which is kind of appropriate because 8.5 is to two significant figures, that would obviously equal 5.5 meters per second. You don't have to write 2SF after it or anything like that. I mean, you show it in what you've actually done. Okay, now the next problem has you trying to work out it's the time it takes to reach the speed. So again, so you've got a final velocity, VF, equals 24.5. You've got an acceleration of 1.5 meters per second. And once again, you kind of, and your initial velocity is VI equals 0. Now that may or may not need that. So now you're looking at time. So the time equals, so if you've set those out, it kind of makes your life easier. So once again, looking at these equations up here, we've got VF equals VI plus AT. And actually, the first one you should realize you can use because you've got the final velocity, you've got the initial velocity, which is 0, and AT. You're trying to figure out time. So VF equals VI plus AT. Now, your final velocity is 24.5. Your initial velocity is 0 plus 1.5 times, 1.5 times by t. So that ends up becoming 24.5 divided by 1.5 will equal t. So if we do that, divided by 1.5, we get 16. T equals 16.333. And again, if it's 2SF, that would simply be time equals 16 seconds as a final answer. Okay. All right, next problem we're looking at is circular motion. Okay, in circular motion, draw the centripetal force. Now that always acts acts towards in the middle of the circular, basically the middle of the circle. So that's that. The tension force would be acting the other way if you had to draw that in, but you're not being asked about that. Okay. What creates a central pedal force? Well, one way of easily identifying this, if this force wasn't in place, this would go off at a tangent to the line, and actually it's going this direction, isn't it? So it would go that way. That's the velocity if you're asked to kind of draw that in. And so if that force wasn't in place, it would go off in a straight line like that. So that's obviously the tension force in the actual rope itself. Now in the next one, it's asking for velocity. Now it is just distance divided by time, but the distance we're talking about is the circumference of a circle going all the way around, which is going to be the circumference, which is 2 pi r, over the time it takes to go around, which is 1 period. So if you didn't know what 1 period was, if they hadn't given it to you like that, you may have to work it out based on some other information. But at this stage, so we've got 2 pi times 3.6 divided by 0.15. That will equal whatever the velocity is. So we'll just work that out. Okay, I'm doing that calculation. We get 150.79 meters per second, which would be 150 meters per second. Okay. All right. Okay, now the important thing to realize with circular motion is that the formula are typically different. So for this one, the force is going to equal mv squared over r. So you already have the velocity for calculating this. You know the radius is going to be 3.6 meters, and the mass is 2.5 kg. So you just have to put those in and calculate them. So that's going to be Fc equals 2.5 times 150 meters per second squared, so and divide by 3.6. Now do the squared first, just to make sure you don't kind of times something together and then square the whole thing, which of course would be wrong. So 150 squared is going to equal 22,500 times 2.5 divided by 3.6. So what's that going to equal now? If we do that, that equals 15,625 newtons. Now if we were going to do that to two significant figures, that would be 16,000 newtons. It all depends on how it's done in terms of how many significant figures are in the question. Now for this one, you're circling around. What creates the centripetal force? This is just really trying to get you to think about the forces involved. So if you're a car circling around, the centripetal force is directed inwards, but what's stopping you from going out that way? Now, that's the tires. So it's the friction, it's the grip or the friction between the tires and the actual surface that's creating it. Oops. Between the tires and the road, if you're on the road. Okay. Now, if you cut a string, if you're going around in a circle and that kind of string gets cut, then you're going to go at a tangent to the circle. So you just basically have to. Okay, so the ball would travel in a straight line to the tangent, or at a tangent of the circle, at a tangent to the circle. It's probably not the best wording. At a tangent to the circle. Okay. Okay, so that's that question. Now we're into the excitement that is momentum. Okay, in momentum calculations, you make an assumption that momentum is conserved. So that basically means the momentum before equals the momentum after. So I'm not doing a full answer here, but that's what you'd be talking about, and that no external forces are acting on whatever's involved in it. So here's just a typical normal problem where you've got two carts that are colliding. So you've got the yellow cart, 14.5 kgs, is going 4.6 meters per second. So it's your mass times your velocity, which is going to equal your total momentum. And that has to equal the mass of this. So I'm just seeing what my question even asks here. So I think this is to carry on here. So after the collision, the car yellow has a velocity of 3.8, so that's times by 3.8, plus it's got to equal the second car, 12.2 times whatever velocity that's travelling at. So once you've set that up, it's just a matter of solving it. Okay, so this is a total momentum before. I'm just leaving out units at the moment. And that's going to equal 55.1 plus 12.2 times v. So this will move over to this side, and that's going to subtract off that. And that's going to come something like 16.2 equals 12.2 times v. So that means if you divide 16.2 by 12.2, that means your velocity will equal 1.3 meters per second. So that's really the answer to that question there. I don't know why I divided that up. Okay, now this next question, which I've just realized was there, is to do with force and impulse. Now, if you want to do this calculation, one of the important formula is force times time equals change in momentum. So the change in momentum is just your final momentum minus your initial momentum. So that is 55.1 minus 71.3, and that equals minus 16.2. Now the minus sign just means there's a change in direction, which is really to do with the fact that it's just slowing down. So that's really all it means there. So if we put that in there, we've got force is going to equal your change in momentum, which is 16.2, divided by your time, which is 0.12 seconds, and that's going to equal 135, I think. I'll just check that. Okay, that's 135 newtons, and if that was to 3C, that would be 140, I guess, but I'm just going to leave it like that at the moment, 135 newtons. But I think in the above question, I realized I made a mistake in terms of I should have given a direction, and that is east as well. You would get marked down for not putting a direction. So if it asks for that, just remember you've got to put it in. Okay. Now this is to do with those momentums where you've kind of got them going in opposite directions. So that can be kind of explosion type things. So that means the momentum before is 0, and the momentum after is going to be 0. So in this situation, if we've got this bullet, which is 20 grams, now we've got to put that into kilograms, so it's going to be 0.02 kgs is going to be your bullet, and that's going to travel at 250 meters per second. So that's got to equal the 6 kgs times whatever velocity that goes backwards. So these are reasonably straightforward. 250 times 0.02 equals 5 kg meters per second equals 6 times v. So you just divide that in, and you should end up with v equals, so it's 5 divided by 6. In other words, that'll equal 0.83 meters per second. Okay, and I'm going to stop at this stage